All right, let's jump right into this explainer because we are looking at a massive paradigm shift today regarding the future of our urban infrastructure. Now, if you work in city planning, zoning, or public works, you already know that trying to forecast what your city is going to look like decades from now, well, it can kind of feel like gazing into a very cloudy, chaotic crystal ball. But a fascinating new study out of the Complexity Science Hub and ETH Zurich is fundamentally changing how we look at the map.
As city planners, you are constantly bracing for exponential sprawl, right? You're looking at your zoning maps, your transit grids, those looming housing shortages, and you're probably asking yourselves if the human race is inevitably heading toward endless, unmanageable megacities. It's a genuinely daunting prospect. Are we really all just destined to become tiny cogs in these massive, sprawling urban machines?
And look, that anxiety is entirely justified when you look at the standard forecasts we've been relying on. The current, frankly terrifying trajectory suggests that over the next 25 years, a staggering 1 billion people are going to move into cities globally. That is 1 billion new residents who are going to need water, electricity, transit, and housing.
To put that astronomical number into perspective, as this quote from the source material highlights, planners are basically being asked to accommodate the equivalent of a brand new New York City every 60 days. Just imagine the logistical nightmare of that. You're building out the 5 boroughs from scratch, over and over again, 6 times a year for the next quarter century. No wonder everyone is stressed out.
But here is the massive plot twist from that new study published in PNAS. By the year 2100, we'll actually have 450 million fewer people living in large cities than those current trends suggest. Let that sink in for a second. The researchers found that simply extrapolating our current explosive growth trends into the future is actually a deeply flawed methodology. And that downward revision of 450 million, that difference is significantly larger than the entire current population of the United States.
So what's truly fascinating about this final breakdown is that the data implies only 38% of the global population is actually projected to live in large cities of over 1 million people by the end of the century. The remaining 62%, they'll reside in smaller cities and rural areas. This absolutely upends the idea that the entire globe is inevitably going to be swallowed up by sprawling dystopian megacities.
Which brings us to Section 1, Superlinear Effects, and the trade-offs of million-person cities. To understand why this massive downward revision matters so much for your long-term zoning and transit plans, we need to quickly look at exactly what drives this dynamic.
When people move to a million-person city versus a 10,000-person town, the impacts don't just scale up linearly. They multiply. A massive city makes its residents almost twice as productive and more than 3 times as innovative. And that is a powerful driver for economic growth, which is exactly why these cities act like giant magnets early on. But the trade-off is absolutely brutal. Residents suffer through more than double the traffic time, which, if you've ever driven downtown at 5 p.m., sounds pretty spot on, and nearly triple the disease risk. Eventually, the friction of all these negative effects starts to counter that initial magnetic pull. Moving right along to Section 2, redefining boundaries and how the data was found. So how exactly did these researchers discover that the chaotic growth of these high-cost, high-reward megacities is actually slowing down? Well, it basically comes down to throwing out the old maps.
The researchers realized that relying on official administrative boundaries wildly misleads forecasters. Think about it for a second. The functional, lived-in reality of Paris is much, much larger than the official city of Paris. New York City is far more than just Manhattan or the 5 boroughs. So, the team mapped out entirely new geographic boundaries. They divided the world into 1 square kilometer satellite grid cells, and they determined whether a cell was urban or rural based on actual built-up area and population, rather than, arbitrary political lines drawn a century ago.
By building 2 major data sets from the ground up using this geographic method, they uncovered the real, hidden pattern of urban expansion. And the scale of this research is literally mind-blowing. They tracked 99 countries, covering 94% of the global population over a 50-year span. On top of that, they historically reconstructed American cities all the way from 1850 to 2020 by analyzing over 500 million individual census records. This wasn't just a sampling. This was a massive, comprehensive tracking of how urban cells cluster and grow physically over time. And that reveals Section 3, the urban life cycle, a predictable pattern. The absolutely crucial takeaway here is that armed with this incredibly accurate data, we can see that urban growth is not a chaotic, endless explosion at all. It actually follows a highly predictable life cycle. Instead of endless sprawl, this growth builds through distinct phases, turning what seems like an overwhelming population boom into a balanced, manageable normalization. In Step 1, early urbanization, Large cities boom because jobs, universities, and hospitals are heavily concentrated there. But as we move into steps 2 and 3, and a country becomes highly urbanized, that initial magnetic pole weakens. The growth normalizes, distributing far more evenly across cities of literally all sizes.
And we can see this play out perfectly in the real world. While early-stage urbanization in less urbanized countries throughout Asia and Africa currently sees large cities growing 7.3% faster than smaller towns, highly urbanized regions eventually see that growth equal out across the board. Look at the past 50 years. Large cities in Europe and the Americas grew at roughly the exact same rate as their national averages. The big cities simply lost their exponential growth advantage.
The perspective this creates is just incredibly relieving. It means your specific city isn't uniquely doomed to a future of endless, sprawling gridlock. Different world regions might look like they're on completely different trajectories right now, but as the researchers point out, they are simply moving through similar standard stages of development at different points in time. Your massive growth phase will eventually plateau.
Now for Section 4, Planning for the Future, Shifting the Paradigm. Knowing all of this, what should you take away from this data as you sit down to draft your decades-long infrastructure and climate policies?
As Frank Nefke, one of the study's researchers from the Complexity Science Hub, emphasizes, accurately knowing where people will actually live is the foundation of every single development plan you approve. If you build infrastructure under the assumption of endless, exponential megacity growth in an already urbanized country, you risk a massive misallocation of resources.
So, the empowering news for you as city planners is this. Urban growth has a natural ceiling. That terrifying megacity explosion eventually loses its momentum. You are empowered to treat urban growth as a predictable, manageable life cycle rather than a chaotic crisis. And crucially, if you're planning for a mid-sized or smaller city, you need to prepare for your growth speeds to eventually catch up and parallel those of your larger neighbors. I want to leave you with this final thought to bring back to your planning committees. If endless megacity sprawl is a myth, how does that fundamentally change your city's blueprint for the future? By understanding this predictable life cycle of urban growth, we can stop fighting phantom sprawl and start designing smarter, healthier, and much more balanced cities for the generations that are actually going to live in them.